My name is Ray Ryan. I'm with Square, and I'm going to talk to you today about some changes we've been making to our flagship app, which this month we're calling Square Point of Sale. It's starting to creak under its own weight, and in particular, a pattern that we have found, kind of a variation on MVP that we, or at least I, call Reactive Workflows. I'm going to talk to you both about the software engineering involved here, what the pattern is, and how we're trying to organize the code, but also some of the social engineering component, how we take an app of this size with a lot of people working on it all at once and give ourselves permission to make this kind of change. This is pretty much the talk that I just gave at Droidcon New York, so if you saw that, thanks for coming to the dress rehearsal. I have played with the timing a little bit, so hopefully I'll actually be able to discuss the slides at the end instead of saying, gosh, I ran out of time. We'll see how that goes. So to start with, let me tell you about how the app works before we started trying to make this change to it. We work in a style that you could think of as key-based MVP, which is basically the MVP pattern that everybody seems to use in some extent, just some way, with a kind of URL-style navigation scheme behind it. So we do that with a library that we open sourced a few years ago called Flow. The basic idea is that every screen, every location in the app is identified by a unique key, a value object, like a URL, that defines exactly what objects are live right now and what screen should be in front of the user. So things get kicked off by we calling Flow saying, show a particular key. That key is bound to a particular view, which in turn pulls in a particular presenter. The presenter is tied to the appropriate model objects, and life goes on. To talk in more concrete terms, in our app, maybe one of these screens would be the cart screen. So the key named cart screen says, hey, time to load up that cart view layout and inject the cart presenter, and let's grab some of the item library and cart model objects to get our business done here. When it's time to navigate, when the user clicks on a button or something to take us to the next screen, we call Flow, our navigator. The next screen comes into play. Come on, animation. Identifies the next view, the next presenter, different set of model objects, and so on. Hopefully this is not terribly foreign to what most of you are doing as well. What we found is there's a few warts in this kind of organization. One of the first ones is we frequently wind up with a kind of circular relationship between the view and the presenter that drives it. So the presenter might tell the view, hey, I'd like you to show a money amount, and the view might call back to the presenter, well, what's the currency object that we're using right now? And this kind of back and forth, nobody's really in charge kind of thing can get a bit hairy to track down. It's not a showstopper or anything, but it comes up a lot. A bigger problem that kind of creeps through the code is navigation logic, kind of tying things together in ways that you don't necessarily expect them to. So for example, we've already got our cart screen being in charge of telling us when it's time to show our charge screen, so those two classes know about each other. And from the charge screen, we might need to navigate to the tip screen because, you know, most merchants are hoping for some generosity. From the tip screen, we're going to go to a signature screen so somebody can actually sign for this credit card payment that they've just taken. Except sometimes maybe it's a plumber who's taking your money from you, and you're not going to tip your plumber, so we have to have logic in the charge screen to know that it should go straight to the signature screen in certain cases. But anyway, we keep going. We get from the signature screen to the receipt screen, unless this is a really cheap payment where a signature isn't actually required. And of course, the charge screen has to know about that also, because maybe we skipped the tip screen like we did before. And that's one more trace. And then finally, of course, eventually the charge will be done or the charge will be canceled. And so every one of these screens has to know how to get back to the cart screen. Now this is possible to clean up, and we've gotten into a habit of introducing what we've started referring to lately as runner objects, some helper that can be in charge of this knowledge of the relationship between the various screens, try to sort of tie things up and centralize it. But this is nothing formal. It's nothing that we can count on ourselves to do. It requires maintaining discipline, and sometimes extra concerns can leak in, like the cart screen might need to know how to go to the settings screen, and it'll just do that itself. So besides having our navigation logic starting to kind of crawl throughout the app and tie things together in an unfortunate way, we also wind up with knowledge of our business logic, or rather the business logic itself, finding convenient homes outside of where it really should be. Consider another scenario where we're taking a charge and our card reader business object lets us know that a credit card swipe has happened, and our charge presenter is going to hear about that, and it'll pull off the card info that's related and stick it into the bill that we're building at the moment, and then our payment runner will be told, hey, time to go to the next place. payment runner has to think about that. Am I going to show the tip screen? Am I going to show the signature screen? Maybe I don't have to do either of those things, in which case I'm going to have to talk to the bill object myself and call that finish thing. And all of a sudden, we've got knowledge of how to deal with these business objects. Some of it's in the charge presenter, some of it's in the payment runner over there. Kind of everybody's getting in on the act. Nobody's really in charge. And you can see where that might kind of get out of hand. Still, though, despite those warts, this has been a pretty successful model for us. We've had, over the years, a ridiculous 200 contributors to the application, and I think I actually believe that number. Not every week, but things add up. There's easily 300 screens in the thing, and that's growing all of the time because we keep getting told to add features, and nobody ever asks us to take a feature back out. But we're still getting this thing out the door every 2 weeks, so something must be going right. But something going right for 4 years can really get out of hand pretty eventually. We found ourselves about a year ago with a 12-minute clean build on a good day, 2 to 4 minute rebuilds on pretty trivial changes, and as Pierre and Ella discussed yesterday, a real spaghetti of the commons issue with that business logic that I talked about, just crawling from convenient to presenter, convenient to presenter to convenient to presenter, and it's just hard to know what's safe to change and what's not. Meanwhile, our friends working on the iOS app have the same problems and more so, where we found ourselves with presenters full of business logic. They found themselves with view controllers full of business logic, and also a lot of what would Apple do syndrome, bad habits that have permeated the community, like an abuse of static singleton objects, core data creeping into public APIs because it was so convenient 4 or 5 years ago. And where we have nice text-based layout files, they have a plague of zib and storyboard files that might as well be binary if they aren't. Basically, on both sides of the mobile divide, we found ourselves with a feeling of learned helplessness. More than 750,000 lines of code in each of these apps. As I said, 300 freaking screens in this one little thing on your phone. Nearly half of that is in the payment flow itself. That's an honest-to-God diagram of our payment flow. We instrumented the thing and stuck it into Node4j and then fell off our chairs. We found ourselves at a point where it's not practical for somebody to kind of just roll up their sleeves and crawl in there and start to try to clean things up in a weekend or maybe a week or two. It's gotten to the point where we're all scared all the time. You've got iOS developers saying to each other, the Android team seems to have their act together with these model classes. Maybe we should be more like them. And the Android developers saying, no, we're all terrified of our payment flow. It's just not been a good thing. So we decided to do something about it. And we did that by actually setting up a few people whose job it was to make things better. And in order to make things better, step one is to try to make it possible to make things better. If you've ever been in the position of being the person who's going, or the people who's going to try to clean up everything and chart a new direction, if you have thought about it at all, you should be terrified and just go to try to find some other job someplace because it's a really hard thing to succeed at. To try to give ourselves a chance at actually pulling it off this time, we took several steps back and tried to get a really clear picture of what the problems actually were, what our end goal, our picture of the perfect environment actually would be like, and only at that point started trying to describe what it is that we'd like to do and set up a plan for how to get there. That in particular, the idea was to set ourselves up to look 2 years in the future and imagine what could life be like in 2 years from now. What would I like it to be like every day when I come in to get to work and start to build new features on this thing? And the 2-year time frame isn't chosen arbitrarily. It's meant to be kind of just far enough away that you can imagine almost anything being possible. There's a lot you can get done with a few people working full-time on something for 2 years. But at the same time, it's still near enough from now that you can actually imagine the particular date and realize that it's terrifyingly close and there's almost nothing that you can get done in that time. So kind of balance excitement with still some healthy pragmatism. And again, backing all of this is the realization that you can't just jump in and start fixing things that you know are obviously wrong, because if you really could do that, you would have done it by now. Things are at a scale where you need to be thoughtful about what's going on. So we went through this exercise. We talked to a lot of teams that make a lot of contributions, and we saw a few common themes. The edit compiled debug loop is ridiculously painful, like I was saying. The code is complex, and we're all scared of it. Everything is too tied together. We don't know what to do about it. And we're all software engineers in this room. The answer to all of those questions, how do you deal with that, is obvious on the one hand. You just got to modularize things. You got to tear it apart into smaller code blocks because they can build in parallel and those will go faster. Smaller code blocks have fewer entry points and fewer exit points and fewer cross dependencies. It's easier to see what's going on. If you do it right, you wind up with a nice DAG, no more circular dependencies. That's easy to say, but again, it's hard to do. Again, Pierre and Ella got a great talk out of just the mechanics of how to identify the bits that you can actually chop off and successfully do it. But there's also the particularly interesting problem of how do you divide up UI code that way. It's one thing to find API entry points and exit points and factor out common dependencies. It's another thing to find a way to come up with a kind of common way of expressing your UI so that you can have a kind of a la carte approach to how you assemble your app without winding up with things that are so incredibly siloed that you can't navigate from the middle of one to navigate to another, that kind of a thing. And you also want to be working toward an architecture that's going to kind of sustain itself. Remember that we gave ourselves a 2-year time frame to think about this with. We also gave ourselves, our team, a 2-year expiration date. We don't want to be the people who clean up the things and we'll keep on cleaning up the things, but rather we want to establish habits that will naturally lead people to write new stuff in a modular way rather than piling on more spaghetti. You've got to set up what a friend of mine used to call the pit of success. The obvious and easy thing to do also happens to be the right and scalable thing to do. So what we did is we went off to the future and we came back with the software manual, the architecture manual that we wanted to be true within that 2-year time frame, or at least its table of contents. And kind of page 1 of that book, or Google Doc, laid out a few of the core principles that we wanted to, we took for granted, we wanted to communicate that everybody else should be taking for granted too. The first and most important one probably is that immutability is assumed. Shouldn't be controversial, but is whenever you're crossing an API boundary, the only thing that should be coming across that boundary is some kind of an immutable object that nobody is going to, the vendor of the object isn't going to accidentally change it out from under you. There's no need to be polling on it, and there's also no chance that the recipient of the object is going to accidentally clobber some global value that is used by 25 other people. Second, and just as important, be reactive, which basically distills to push, don't pull. On any public API, there really shouldn't be a get foo method. There's no get user. There's subscribe and let me know who the user is once you know it, and keep me subscribed and push changes to the user into me as they're available. To Android developers, that obviously means RX Java, but Reactive, you should bear in mind, Reactive is a pattern. It's not a library. And remember that we're trying to solve a lot of pain for iOS developers as well, who are either working in Objective-C, where there's pretty much no practical reactive library, or if they're lucky, they're working in Swift, where RX Swift is probably okay, but there's still some convincing to do. Regardless of what tools get used to actually push this pattern in place, the main point is to be embracing the inherent asynchrony of working on any kind of an app with the UI, in particular any kind of a client-server app. And we definitely want to wind up, like I said, finding ourselves patterns where the separation between UI and business concerns happens automatically or naturally. And ideally, we should be finding ourselves with a uniform API across the 2 platforms. If an iOS developer is working on screens A, B, and C and finds himself in the Android code base looking at those similar screens, really should be talking to very similar underlying objects, or something went wrong. Every time our 2 apps do something differently, it's a bug. If we're doing our job right, those bugs shouldn't happen, and the API should be consistent as well. So when I say uniformity, probably the first thing that comes to mind is code sharing. And the answer to, is this a code sharing talk, is maybe, probably not, no, but sometimes. The goal of the patterns that we laid out was to make sure that code sharing was possible when it was necessary, but by no means expect it to be what is always going to happen or even common. Code sharing People will think about that frequently as some kind of a panacea. Oh, if I only could write this write this thing one time, I'd never have to do it again, and I'd be getting my stuff done twice as quickly. That's just never true. The multiplier is going to be something a lot larger than once. And regardless of the approach that you take, any code sharing scheme, you have to keep in mind that for somebody who's consuming that code, it is foreign code. If I'm writing Java code that I'm going to share with iOS victims through J2OBC, I'm going to have to put a lot of effort into making sure that the API that gets generated is actually something that they can consume. And sooner or later, they're going to have to debug across that boundary from the Swift code or the Objective-C code back into this generated J2OBC code. And it's a good bet that that's going to be perhaps not the most pleasant experience. If we're trying to share the code by writing C++, now Android and iOS are both having a terrible time, and Android's probably having even a worse time. Maybe we're going to use some clever JavaScript hack or something. Again, it's going to be foreign for everybody. And there's other ways to do it. There's other ways to get this kind of consistency. We've had some success, actually a lot of success, with having some of our core tax calculation code is driven by a unit testing suite that is defined by a bunch of JSON files, where the files declare, here's the inputs we expect, here is the outputs that we expect. Now go write an Android and an iOS implementation of a test runner that can consume these things, so that we can know that the related code for those two things is actually producing the same results. People get really cranky if you add up 1 and 1 and get 2 on one side and 2.5 on the other. You can also get to this kind of uniformity just by simple things like using protocol buffers to define whatever API it is you're talking client to server. Probably half the people in here are doing that already. You're sharing code. Congratulations. But the main point to make, the main thing to keep in mind when looking at code sharing like this is that second point. Writing is actually not all that hard. I have to write it once. I have to write it twice. I'll get over it. But whatever I write in a week, I'm going to be living with for a year or 5 years. And that maintenance, that debugging, that keeping it going, making sure people know how the strange joint build system works, that's a tax, and you pay it for a very long time. Nothing against code sharing. We're doing it in some very important places, but it's probably always going to be the exception rather than the rule, at least for us. All right, so enough meta conversation. How am I doing on time? Woo. Let's talk about the actual patterns that we've settled on, how we're going to start organizing our app. We came up with kind of two terms that were new to us, workflows and bricks. I'll go into more depth on that. The bricks are kind of the base, and this is meant to be, it's a odd term, and that's on purpose. It doesn't mean very much, so we can make it mean what we wanted it to. The basic idea is that the bricks are the kind of snap together business logic model objects that we snap together to actually define our core behavior, kind of microservices for your app. On top of that, we have a workflow layer. And this is where, if the bricks are modeling our business logic, the workflows are modeling our UI, how we actually present the business logic to the user, what's a screen, how do we navigate from screen to screen, what is the data that is painted on the screen, and what events come back in through it, and that kind of a thing. And then finally, up at the top of that, we declare some bindings on a view factory to render the workflows in a top-level container, like a frame layout or something, that the user can actually see. The bottom two layers here, the workflows and the bricks, are, or can be, asterisks, platform neutral. There's no reason that I couldn't, if I wanted to, write my workflows and bricks with J2OBC or C++ or whatever else to be shared, and then restrict my iOS or Android specific concerns just to that top layer there, where it actually render views, inflate nibs, show stuff in a frame layout or a top view controller or whatever. So more depth on these layers, starting from the bottom. Let's talk about the bricks. Brick actually isn't the term that we use inside the walls at Square. We use a different term, but it's somebody's trademark, and that didn't seem like a wise thing to have recorded out on the internet there. So we'll stick with the brick term here. A brick is, like I said, basically a model object, a business model object, and it's a reactive business model object. We went with this term again because it doesn't really mean anything. We couldn't say module because there's a specific meaning to a Gradle module, and we couldn't say bean because that certainly means something, and we couldn't really say widget or component or so brick, thing you can snap together. So like a bean, but with a reactive API, where a reactive API means I can push values into one of these things, like I can have setter methods on it, but I only get state out by subscribing to observables. It's that push don't pull principle again. So when I need to mutate this thing, I will push something into it, and sooner or later that may or may not have the side effect of tickling an observable to update the value that this thing represents. What I'm never going to have is an explicit get method like that. I'm repeating myself, but it bears repeating. And then finally, the brick is kind of the from the point of view of the rest of the app. This is the fundamental building block for each. This is the only thing that's allowed to think about concerns like I/O, like making RPC requests or whatever else goes on there. We don't expose these services out across the app. We try to encapsulate them in each of these little brick logics. Just like when you look at the top of a snap together plastic children's building brick, you've got this nice little tidy set of circular things on the top. When you turn it over, it's kind of messier. The messier stuff is there on the bottom. So if you're trying to, so this is where what's my point here? Why did I put the library names? We're trying to build these with a reactive API, and these are some of the libraries that are helpful to actually achieve that. Retrofit is really good at working with RxJava 2 to make every service call something you can observe. SQLite and SQLDelight do a wonderful job on the other side. What's interesting is that, at least in theory, both of those, Retrofit and the SQL asterisk libraries that I can never remember which one does which, but they rhyme, can be cross-platform if you put your J2UpC together just in the right way. If that's not really a concern, Rx preferences or rooms are also a nice way to go. But that's the basic idea. Another nice thing about bricks is, just like you remember from childhood, you can build big things out of small things. They assemble together pretty nicely. One brick can subscribe to another and so on. If you do something like that, you want to make sure that the fact that it's multiple bricks snapped together is an implementation detail. Give it a nice consistent API of its own. And as you build things up this way, maybe some of them are cross-platform, built with JavaScript, built with J2UpC. Maybe they aren't, but your consumers never have to know about that as long as you keep this API, this kind of push, don't pull reactive style. So let's get a little more concrete about what a brick might look like. Let's imagine that we had a mission-critical tic-tac-toe microservice that we want to expose in this style. So we might define its overall state as a set of data classes and enums. If I'm playing tic-tac-toe, I need to know whether the game is being played right now. Did it end in victory? Did it end in a draw? Each cell on the grid is either empty or has an X or an O. I've got a player class. I've got a GameState class defined in terms of those. And all of this snaps together into a complete and immutable snapshot of complete state of a game or a game session. The API for the brick itself, the game runner, could look something like this, where I've got functions to either start a new game, given a couple of player names, or to restore a game. I've got a function to take a square when the appropriate thing happens, and I've got a function to quit the game early if I want to. And in order to actually render the game, I've got a single way to get state out of it. This one game state observable that I subscribe to, it gives me the initial state, and it gives me the updates. That's all of the traffic that I can do in or out of this thing. Another approach you could take with something like this, let me go back a slide. So this is clean and it's easy to understand. It's also a really nice kind of boundary to refactor to when you've got a mess of stuff that isn't reactive and you wish it was reactive. If you can find a place to introduce this interface and hide the concerns that you haven't tied up to something nice yet, at least people at a higher level can start dealing with it in a reactive way. But there's kind of an impedance here where I pretty much have to subscribe to that game state in order to hear stuff, and I've got these several entry points to push stuff in. It's not so bad for the consumers of the brick, but it means that whoever is implementing this brick has to deal with those concerns separately. I don't know if somebody's going to subscribe to that game state before or after they start making these method calls on me. If I'm implementing this, I've probably got a behavior subject or something that is modeling the game state. I might have another behavior subject for each of these input methods. I'm at a reactive, non-reactive boundary, which involves more coding than you'd normally want to deal with. But again, it's not a terrible way to work. It's not an awful API to work with, and it is a nice thing to refactor toward. If you've been at this reactive game for a while and you can kind of assume reactive style code above and below, a command pattern might be something that's both easier to implement and actually possibly more pleasant to use. So for example, our game runner object could look something like this, where we've got a sealed class defining, replacing all of those individual methods to start things off, to mutate things. And instead of exposing an observable that you can subscribe to directly, we make our state available as a transformer, a function that is able to take commands, a stream of commands as input, and occasionally burp out game state objects as output. And there's no need to subscribe anywhere along the way if I've got things that I can build together this way until I have my entire pipeline assembled. I can subscribe at one point and off we go. That's the theory anyway. We haven't built a whole lot of stuff in this style. We're still trying to just get to the ground level. If you want to read more about working in that way, do a Google. I'll put the Google terms up on a slide at the end. Don't worry about taking pictures. So anyway, them's the bricks. What about the workflows? So let's go back to what we're trying to move away from, the presenters and runners that are talking to model objects, and we're navigating around through these key objects. Just reiterate what the problems were that we were trying to deal with. We've got the circular relationship between view and presenter, which is minor, and we've got this bleeding across the app of these navigation concerns and business logic, which is not minor and has led to everything depending on everything else, and there being no central point for knowing how do you take a credit card payment again? And the navigation concerns that bled it all over the place. But if we look at these boxes here, it's really hard to articulate exactly what the difference is between a presenter and a payment runner. They both talk to model objects. Either of them could wind up making these navigation calls for us. About the only difference is that a presenter has a strange and arbitrary one-to-one relationship with a view of some kind. One-to-one is normally kind of a smell, and maybe all we're after is something that actually unifies these two tasks. So you push these together, and what comes out is what we're calling a workflow. So like the brick, the workflow tries to keep you reactive. The rule is that it's got an input of some kind. I can start my workflow, and eventually the workflow will end, and it will produce a result. That should be single of R. I changed that. Well, that's fine. So it starts, it chugs along, it does this workflow thing, and then sooner or later it says, okay, I'm done. Maybe it was an authorization workflow, and it says, hey, I'm done, and here's the authorization token. Maybe it was a credit card payment, and it's going to let you know that the payment ID is there, something like that. While it is working through its states like this, off on the side, it's exposing an observable of workflow screen objects. Screens are, a lot like view models, except the view model term was taken both by Android recently, and thank goodness that they did. The view models and the architecture components look wonderful. It also had meanings among our iOS code base that was never quite exactly what this was, so we needed a new term, and so workflow screen. But it's the same basic idea. Each of our workflow screens is kind of a tuple, or really a triple, with a key, a name that uniquely identifies this particular set of stuff you want to put in front of your user. An observable of screen data, which you also might have called view model, except view model meant something else too, and so screen data was nice and neutral. Screen data is an immutable object again that provides all of the information necessary to render this particular piece of your UI, and then updates as things need to change in front of your user. And then finally, the workflow triple exposes an event handler of some type, an interface that defines all of the events that we can expect to handle, all the button clicks, all of the text entry, that kind of a thing. The full contract for this particular screen of your app. So getting less abstract, Suppose we had a workflow for authentication, maybe two-factor authentication. It's going to have three screens, the login screen, the authorizing screen, and the second factor screen if you have that set up. The code for that would probably look something like this. Also, a disclaimer here, I don't actually write Kotlin. I did an automatic conversion of a lot of this from some sample Java not long before I gave the thing. There is no bonus for finding bugs in this, but you can feel really superior. Anyway, so our login screen defines exactly what happens when we're at the login state. There's a key to identify it uniquely, which we'll use later. It has a very simple event interface. There's all you can do on it is try to log in with a submit login event, which takes your email and your password. And then finally, it's screen data. In this case, it's just an observable of string. There's nothing interesting for this thing to tell the user except possibly you screwed up. There will be error messages coming if there's an error message to display, or an empty string if there's nothing wrong right now. Just a little tangent here, a more interesting screen, and this is one I actually did take straight out of our app, would have more complex screen data. Like this is the screen that confirms that you want to save the customer's credit card, and or no, it confirms that you're charging. I forget what it does, but it could be showing you the amount that's going to be charged and what's the customer's name and the obfuscated credit card number, and I don't even know what an instrument index is, but that's the idea. It's just the blob of stuff that defines what you're going to render. So that's what our workflows are emitting. How are we actually consuming all of that stuff to actually get it on the screen in front of our users? This is where we finally are getting into platform-specific code and UI-specific code. We're going to, in the, whoops. Oh, well. Anyway, the three boxes at the top that I keep forgetting to read across are our view factory, which is a very declarative thing that says, given the workflow with this key, here's the thing I want to inflate to display its data. The container, which is the thing that manages interpreting these keys and actually making animations happen between screens and that kind of a thing. And then some kind of a root view, just a frame layout, or maybe a set of frame layouts if you're doing something layered, that kind of a thing. Our view factories and the code that we're doing right now look a lot like this, where I'm going to just have little declarations. Whenever I see the login screen key, it's the layout login that I'm going to inflate. And then finally, I'm going to provide a factory function that, given a screen of that kind, that instantiates a coordinator of that knows how to deal with these logins, these screen objects, and knows how to deal with that layout. So coordinator is a new term that I just snuck in on you. What's a coordinator? Coordinator is a cute, tiny little minimalistic library that Logan Johnson at Square introduced a year and a half ago that provides just enough Android lifecycle for you to get your work done and not a drop more. They're tiny little objects that, given a view, can let you know when the view has been attached to a window and when the view has been detached from the window. And we have found that that is 99% of the lifecycle that we actually need to get any interesting work done. So our login coordinator here is going to set itself up. It'll be told to attach to a view. It'll do all of the usual stuff of find views by IDs and set them into variables. It'll set up a click listener, so when somebody actually hits our login button, we'll actually talk to that event handler thing that came in with our screen object and tell it that the login happened. And we'll hold on to a subscription to that screen data so we can render any errors as they show up. When we detach, we tear down that subscription. And what I've shown you here, the authorization factory and the login coordinator, that's pretty much all of the Android-specific code that has been needed to happen here outside of setting up a nice XML layout file somewhere. Look for Square coordinators. I'm a big fan. I doubt he's put a 1.0 on it, but the code hasn't changed in 6 months because it hasn't needed to. So we've got workflows. We've got screens. We're actually rendering them for our users. So we've gotten a good picture of our workflow black box from the outside, but how do we actually implement these things? What do they look like on the inside? More code. Most people are awake, good. Our auth workflow looks something like this. Remember that we have two parameter types on there, something that comes in and something that goes out. Auth workflow doesn't start with any particular interesting information, so it just starts with unit, one of the two Kotlin moral equivalents of void, except it doesn't involve you ever dealing with nulls, which is nice. And then when our auth workflow ends, it's going to provide some kind of a token of some kind. It is also going to actually implement those event interfaces that each of our screens was declaring. So if each screen is kind of the contract of, here's the conversation I expect to have with the user on the login screen, on the second factor screen or whatever, the workflow is the thing that's actually going to implement all of those event interfaces, accept all of those signals, and churn through its private state to handle that. It's probably going to have some notion of what the current screen is that people can subscribe to actually know what to render. And it's also likely to be maintaining internal view model objects for each of these bits of state that it has to display on its various screens. So remember, our login screen had an uninteresting screen data of a string, and so we'll hold on to a behavior subject of whatever login message we might need to be, login error message we might be displaying. We have 3 screens, and we have basically 3 subjects that we maintain to model what's actually going to be showing on those screens. And then the kind of our main method here, our screen method that people are subscribing to in order to actually render this stuff, might look something like this. Given that current screen, we're going to map on what key is associated with it, and if we've told ourselves that the current thing we should be showing is the login screen, we'll instantiate one of those, and we'll pass in ourselves as the callback for all of those event methods. Same for the auth screen, same for the second factor screen, and so on. Basically, each of these login screens and the interfaces they defined wind up acting as a closure on the workflow. So the workflow can accept any of the possible events from any of the possible screens that it can show, but by dividing its work into these individual interfaces, we are making it impossible for any particular screen to have the wrong conversation with it, to send an auth screen event, auth2 screen event in from the login screen and make that kind of a mistake. And then finally, what do we do when input comes in? All we've done so far is provide data to be rendered. And what we do maybe is something like this. Receive the login event, receive the second factor event, and we'll just plug it into our state machine. A state machine? Nobody mentioned a state machine. In the course of kind of building the prototypes for what turned into this pattern, kind of gave ourselves permission to remember some fundamental CS, and remembered why state machines are really a great way to build UIs. And they also turn out to be actually pretty easy to write. Whipped off a kind of little finite state domain language in an afternoon that let us do stuff like this. I can declare things like when I enter the authorizing state, I'm going to set the current screen to the authorizing screen key. Whenever I enter the second factor state, I'm going to change my current screen notion to that particular screen. And we can define transitions like when I'm in the login prompt and I receive a submit login event, then I'm going to transition to the authorizing screen, and as a side effect, I'm going to make my server call to do this login or whatever. If I'm in the authorizing state already, I'll go back to the login prompt when I receive an authorized response object, provided, I'm going to return to the login prompt if I received a failure, and I'm going to update the error message to show it. And the code winds up looking like this. You might be expecting me to do a self-promotion of a finite state library that we're going to open source. I'm not going to do that because it's just not interesting. But if you do want guidance on writing one of these things cleanly, look for a post that Andy Matuszek made not too long ago about writing state machines in Swift. It translates beautifully to Kotlin and close enough to Java, and you won't want to write a library either. I've once again kind of blown the time management, so I'm going to skip through the second example of another way to write a workflow that isn't so state machine based. The state machine isn't meant to be like the punchline or a crucial thing here. It's just an example of one way you might want to implement a workflow. Keep skipping slides, Ray. Wow, this is big. So anyway, let's do a quick run through of how all of these moving parts work to try to solidify this in your mind. So we've got our fundamental microservice bricks here off on the side. We've defined a workflow, which kind of seems like a state machine. We've got some management code at the top there, the container and the view factory that knows how to interpret the stuff that comes out of a workflow into something that a user can see. The workflow is subscribing to these various bricks. It eventually decides this is the screen that I should be showing based on the state of the model there. A key is fished out of that workflow screen by the view factory. We inflate a view, put a coordinator behind it. The coordinator sets up a subscription to render the stuff that comes out of the screen data and to plug events back into the event handler there. So we have a nice circular update flow, Redux style, Flux style, whatever you want to call it, but we're still Android developers. And really, that screen data isn't there very long. It's not doing any work. It really is just a tuple, another object that defines a few things. The actual linkage is events coming out of the workflow and, screen data to render coming out of the workflow and events coming out of the view back into the workflow through whatever particular interface is appropriate at the moment. And then probably from there, continue the circle back to the model objects, which might change, might not change, advance the state machine, and so on. And if we eventually we'll decide to display another screen, and the whole thing sets itself up and tears itself down again. One point to make here that you might be asking is, what about the back button? What about the back stack? There is no back stack. Screw the back stack, and to hell with the back button. From the point of view of the workflow, the back button is just another input event, just like the login button, just like the text you typed to log in or whatever else. And some screens you want to go back, and some screens you don't want to go back. It's not at all hard to put together an interface on your views that let them be responsible for receiving the on-back-pressed event from the activity and deciding how to handle it, pass that information through to the workflow. The back is just another event. So one thing, I didn't say that. I should have said that these compose. These compose, and let's talk about how they compose. So we've got a workflow that looks like a state machine. Well, who's to say that the individual states of that workflow can't also be workflows themselves? And we've actually built prototypes like this, where I've got that auth workflow that I showed you and the game workflow that I didn't show you. And when I leave one, then I'll enter the other. And that's all black box implementation detail of this overall app-wide workflow. And this is actually real code that builds a composite workflow, something like that, where I've got a workflow binding where I tell myself that whenever I need to start up the workflow class, I'm going to pull an instance of it out of this workflow provider that I injected from Dagger, probably, because we can't seem to stop using it. And when it ends, it'll tell itself to start the tic-tac-toe workflow. The tic-tac-toe workflow pulls out of that factory, and when the game ends, we'll just start up another tic-tac-toe game, because why wouldn't we? Another way you could imagine composing these things is to maybe have a couple of workflows going in parallel. So I've got a status bar at the top of my app. That means I've maybe got a status workflow that is always running and rendering that part of the app regardless of what's happening elsewhere. Meanwhile, in parallel, I've got a master detail workflow where the master workflow is responsible for the list of stuff on the left of what I'm choosing through and starting child detail workflows as each of those buttons is hit, and so on. I had a couple more points I want to make. I'm going to squeeze them in, jump away from the software, and let's go back to how we're actually executing on this plan that we have, this bill of goods that we have sold ourselves. This is real quick, just a couple points to make. So step 0 is you have to make refactoring possible before you can start doing any refactoring, which more than anything else means you've got to be able to test this stuff, and unit tests aren't enough. We already had pretty good habits on Android of making sure that we were able to write espresso tests using a robot idiom that kind of shielded specifics of individual screens from the tests that are running them. On the iOS side, we also have our KIF framework, which made that kind of thing possible. We've always had on Android a mock service layer. So wherever we make a retrofit call, we always have a mock implementation of that available so that it's possible for us to write stable tests. We invested a lot of time into making sure that iOS could work that way as well. We also spent time making our build speed tolerable. We've been big contributors to CocoaPods on iOS so that we can actually make it possible to divide our app into modules that can't have cyclic dependencies and so on. We've actually been using OKBuck on our Android side because we have abused Gradle so much that it's been difficult for us to update to Gradle 3.0, but that should be changing soon, and maybe we'll stop bringing the OKBuck from. But anyway, initial dues have to be paid to actually make it possible to iterate on this stuff, and you can't change code that you can't test. UI tests are necessary to know that you really haven't broken stuff. Another lesson that we have learned is that you've got to divide first and conquer later, meaning it's a lot easier to just go ahead and find a chunk that you can pull out of the hairball and pull that thing out, making as few changes as possible to its API so that now you can iterate on that thing really quickly before you then go back and try to actually clean up the API and get into that more reactive brick style idiom that we talked about. We've tried to do both at once. That's harder and you're more likely to fail. But going in there and hacking away at things, putting them into smaller parts, however the hell you get them small, pays off quickly, and then you can iterate on the thing to make it beautiful a lot more easily. And then finally, when you're doing this kind of thing, establishing new patterns, establishing new rules, you've got to be really, really visible about it. Lots of public service announcements. The team that is doing this type of stuff needs to be spending as much time writing design docs and standards and so on as they do anything else. If we've grown to the point where we have to have a handful of policy documents, which mostly come down to, God damn it, write a design doc before you build a new feature. And if you're going to be asking everybody to be doing all of this design doc stuff, you've got to make design docking a really painless activity. It's not hard to have a small template, encourage a culture that says, yes, I'll read that really quickly and here's some quick feedback. Google Docs is astounding for this kind of stuff. And then finally, it's really important to be spending time writing how-to guides and putting up sample code. A week I spend writing a sample applet or something like that pays for itself instantly when people say, I need to build a new applet. How do I do it? Oh, go look at the sample, copy paste some code. This is time that is well spent. Then finally, a quick report on how we're actually doing with this. We said we're about halfway through our 2-year master plan and everything. The brick pattern was a pretty easy sell. We've got some fundamental bricks being written on both platforms. The idiom kind of explains itself, even on iOS where there's no React library that they can take advantage of. We've got our first big J2UpC block of code entering production. It seems to be working out. We've got non-toy workflows in development on both platforms. On Android, we're actually snapping together workflows of workflows. And I happen to know there's somebody in the audience who decided on his own to write a new workflow without asking us, hey, should I be writing these things? So grassroots support seems to be taking off there. That is all I have to say. And I don't have time to take questions because I screwed up.